Hello, Professor. My name is Thai. Uh, Today, I would like to present my project report for UAV project. My topic is autonomous tracking, UAV-based skill learning. This is the first part is the slide content of my presentation. That contain the introduction of UAV project, quadcopter control theory, and quadcopter control system, reinforcement learning theory, and Q-learning algorithms. That's machine learning methods that I use, and simulation experiment. The first introduction of UAV project I propose. The purpose of this project is in this area covers research that's utilize machine learning technique for path planning and optimizing application. uh, pro- Propose to study and simulate the UAV control uh, algorithm for motion of quadcopter and develop a reinforcement learning algorithm like deep Q learning, proposing to autonomously control quadcopter motion and train the learning model to keep track the objective. Uh, the figure 1 is my proposal about autonomous tracking quadcopter system. That UAV will keep track the objective in the ground by control the motion uh, of rotor. And the first part, autonomous tracking quadcopter, uh, uh, the subject that my proposal focus on below criterion. That's study and program equation of quadrotor motion, develop and train an reinforcement learning model to autonomously control quadcopter, reach the targets, and simulates this program by MATLAB simulator. And major challenge of this project is train an optimal model to keep tracking the target within the three-dimensional environment. Improve the algorithm by the collision avoidance approach. Includes the obstacle into the environment. The second part is quadcopter control theory. We have to control the quadcopter. We need to control the three-dimensional like three-dimensional position coordinate, like latitude, longitude, and altitude of quadcopter, and it's represented by in Euler space is denoted by peak, rho, and just angle, and the angular rate of body frame of quadcopter. Um, we use the control variable of thrust, total, and moment of X control axis. In the figure 2, we have the model of quadcopter theory. We design as we design a planner for quadcopter to fly from the source to destination and control the peak, rho, and charge angle at the altitude of quadcopter to fly from the source to destination at the plant. And the quadcopter control system that I designed, that attitude and position control is by the state variable of quadcopter as the input of reinforcement learning, or is also as the input of generated motor command system, with the variable denoted by rho, peak, yaw, and thrust command. And that's illustrated by figure 3 in the left. And the trajectory planning is the quadcopter fly to a particular destination, or just track a mobile object underground. And for the reinforcement learning theory, in the fundamental reinforcement learning model, it had a model of agents that interact with the aerial environment. The agent in this is a quadrocopter motor command that generates the action is the action command of each motor to control the quadrocopter, and the current state is a three-dimensional attitude positions of quadrocopter, and in this environment is aerial environment surrounds quadrocopter at that is a desired utility function to return the reward for each right or wrong of action generated by machine learning model to control the motor by a motor command system. The rewards in this is a distance from the current quadrocopter location to the objective or destination. And we illustrate I illustrate the system by figure 4. And in this proposal, I use the deep Q-learning algorithm to as the machine learning baseline to control the quadrocopter. And as I mentioned above, we need a model of based reinforcement learning, so the model will generate the action as the motor command to control the quadrocopter and to interact with the aero environment and get the current location or the distance at the current state, and rewards of the learning model. And the objective of this model is to learn the maximum total reward or minimum the distance between the quadrocopter to the destination. It is mobile object in the ground. And below is the algorithm of deep Q-learning with experience relays model, and I will define in this model will use a deep neural network to train the controller. In the final part is a simulation experiment. We have the figure 5. In the left is a quadrocopter trajectory planning. That quadrocopter will predict and fly fly over the objective. In this the green line is the quadrocopter trajectory, and in the three-dimensional space, and the dots, the black dot in the ground is the quadrocopter shadow, and the red line is the routing part of objective in the ground. The duty of quadrocopter is fly over objective and keep track with the routing part of objective. And in the right is the current state of quadrocopter, or the figure denote the location of quadrocopter in three-dimensional, and in the OLE engine is denoted in the right. And my opinion in this simulation experiment. In this project, I have achieved some significant results that improve my knowledge in quadrocopter control and reinforcement learning implement. In the figure 5, left quadrocopter trajectory path denoted by green line, and black dot is a quadrocopter shadow on the ground. In figure 5, I see The quadcopter is the controller to fly in the air and keep tracking with object that denoted by red line. Machine learning model in this can predict and automate and control the quadcopter to follow the target with the simple rotate line. In this simulation, I just design mm, the a linear line for the objective routing path. And this experiment I have just stopped at combining a simple machine learning model in autonomous control purpose. And however, this topic have many potential to study and improve in the future. Furthermore, is my reference, and I will show my experiment results. This is my simulation video in MATLAB that UAV is the first in the central of three-dimensional figure will fly over the objective is red path and follow the objective and keep track keep a certain distance with the object. Yes, that is my simulation result. I will attach in the report. Thanks for the listen.